Section 2.4 deals with the derivative. So basically, one of the things that the derivative tells us is what is the slope of a line that's tangent, so only goes through one point. Okay, what's the slope of that line? Well, before we can get to that, let's just kind of remember how to find slopes of lines and things of that nature. Let's start with average rate of change, which is kind of another word for slope. So the average rate of change of a function y equal f of x from x equal a to x equal a plus h, right, so movement away from a, is f of a plus h minus f of a all over a plus h minus a. And if we were to clean up this denominator, we end up with the average rate of change equals f of a plus h minus f of a all over h. Well, again, this is really just slope. You may have seen this before in an algebra class, right? The slope of a line, m is going to equal the change in your y's over the change in your x's. Well, it's the same thing that's going on here. So basically what we're saying is, hey, if you've got some function, some f of x, and you want to find the average rate of change from a to a plus h, it's going to be f of a plus h, so the y value, minus f of a, the y value, all over a plus h minus a, or the x values. And again, a plus h minus a, my a's are going to cancel and it just cleans up to that. Average rate of change is known as the slope of the secant line, average velocity, average rate of change in your revenue, average rate of change in your profit, average rate of change in your cost, etc. Anytime you see the word average rate, you're looking at the slope of the secant line. So let's find the indicated quantities for the following. So let's say that I tell you that your function f of x is equal to x squared plus x. And I want to find the slope of the secant line that passes through the points 1 comma f of 1 and 2 comma f of 2. Well, how do I do that? Well, again, the slope of the secant line is this thing, right? So I need to figure out what is f of 1 and what is f of 2. Well, f of 1 is a function value. It says everywhere there's an x in my f of x, instead of writing x, I'm going to write 1. So 1 squared plus 1 equals 2. So f of 1 is equal to 2. F of 2, again, everywhere there's an x in your f of x, instead of writing x, you write 2. So 2 squared plus 2, 4 plus 2 is 6. So then the slope of the secant line, and we're going to write that as m underscore secant, so slope of the secant line is going to be f of 2 minus f of 1 all over 2 minus 1. F of 2 minus f of 1 all over 2 minus 1. F of b minus f of a all over b minus a. In this case, we're saying that this is a f of a, and this is b f of b. So again, what was f of 2? Well, f of 2 we found to be the number 6. And f of 1 we found to be the number 2. So we have 6 minus 2 over, well, 2 minus 1 is 1, and 6 minus 2 is 4. So the average rate of change, or the slope of the secant line from 1 to 2, is equal to 4. Let's look at number 2. The slope of the secant line through the points 1, f of 1, and 1 plus h, f of 1 plus h. Okay, well, again, just like last time, I need to figure out what is f of 1, and then what is f of 1 plus h. Well, f of 1, we've already done that, right? F of 1, we looked above, it's going to be 1 squared plus 1, which is 2. What about f of 1 plus h? Well, again, that means everywhere there's an x in my f of x, instead of writing x, I'm going to write 1 plus h. So in this case, it's 1 plus h squared plus 1 plus h. Well, if I take 1 plus h and I square it, I basically have to write it twice in FOIL. So let's go ahead and write it twice and FOIL it out. And then we're going to combine like terms. 1 times 1 is 1. 1 times h is h. H times 1 is h. And h times h is h squared. Still plus 1 plus h. If I combine all my like terms, I get h squared, and then h plus h plus h is 3 h's, and then 1 plus 1 is 2. So f of 1 plus h is equal to h squared plus 3h plus 2. So then the slope of my secant line is going to equal f of 1 plus h, which is that h squared plus 3h plus 2, minus f of 1, well, f of 1 we know is our 2, all over 1 plus h minus 1. So we have h squared plus 3h plus 2 minus 2 all over 1 plus h minus 1. Well, let's try to clean this up as best we can. Well, we notice here that my 2's will cancel in my numerator, and my 1's are going to cancel in my denominator. Therefore, so far in my numerator I have left h squared plus 3h all over the denominator is an h. Well, each one of these terms has an h in it, h squared, 3h, h, so I can cancel an h from each one of these terms, and I'm left with h plus 3 over 1, or just h plus 3. So the slope of the secant line from 1 to 1 plus h is equal to h plus 3. So what's instantaneous rate of change? Well, the instantaneous rate of change is what happens when we have h, or the movement away from a, equal to 0. So the closer we are to a, which is the movement away from h being 0, is our instantaneous rate of change. This is also called the slope of the tangent line at a point. So going back to our example, what we want is we want to find the slope of the line just at this green dot that I'm drawing here, because we want the movement away from A to be 0. If you want the movement away from A to be 0, then you're going to be at A itself. So that's the slope of the tangent line. So what we're trying to figure out is, what's the slope of this line right here? And the problem is, in math, in order to find slope, what we needed was 2 points. So in order to find the slope of the tangent line, or this instantaneous rate of change, we take the limit as this thing goes to 0. So let's find the slope of the graph at this point, given that f of x is equal to x squared plus 1. So let's find the slope of the graph at that point. Well, whenever you're asked to find the slope of the graph at just one point, you're looking for the instantaneous rate of change, which is just the slope of the tangent line. In order to find that, we're going to use this formula that we've boxed up here. So in our case, a is equal to 1. So we need to figure out, well, what's the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. So in order to do this, I need to figure out what is f of 1 plus h and what is f of 1. Which just so happens, I picked the example that we have above. Notice that our function is exactly the same, x squared plus x, x squared plus x. So we already know that f of 1 is equal to 2. And we already know that f of 1 plus h was equal to that h squared plus 3h plus 2. We already know that because we did that above. So we're not going to do that part again. Okay, so anytime you see the slope of the graph and you're only given 1 point, that means you're looking for the instantaneous rate of change, which means that we're going to plug it into this formula. So we're trying to find the limit as h goes to 0 of f of a. Well, my a is always going to be the given. In this case, it's 1. F of 1 plus h minus f of 1 all over h. So let's plug in what we know from example 2. So we're looking at the limit as h goes to 0 of, remember, f of 1 plus h was our h squared plus 3h plus 2. I need to subtract off f of 1, which we know is 2, and we're putting that all over h. Well, let's clean this up before we take the limit. Again, my 2's cancel, so I have the limit as h goes to 0 of h squared plus 3h all over h. Well, just like last time, everything's got an h in common, so I can cancel an h out of each one of those. So this is the limit as h goes to 0. This was just h, this was 3, and this is 1, of h plus 3 over 1, and we don't really need to write over 1. Now we've cleaned this up, so let's take the limit. So the limit as h goes to 0 of h. Well, again, this is just plugging it in. Remember from section 2.fun, how do we find these limits? We just plug them in. It's just direct substitution. So I plug in a 0 in place of h. So 0 plus 3, which is equal to 3. What does that mean? That means the slope of the tangent line in this case is equal to 3. So the slope of the graph at the line 1 comma f of 1 for f of x equals x squared plus 1 is equal to 3. So the slope of the graph we obtained in this example, again, is the slope of the tangent line at x equal 1. If we wanted to find the equation of the tangent line that passes through this point, we're going to use what's known as point slope form. And point slope form is y minus y1 is equal to m times x minus x1. So if we wanted to find the equation of the tangent line at 1 comma f of 1 for f of x equals x squared plus 1, and again, I'm just using the same example so that we just build on what we've been doing. So if I want to find the equation of the tangent line, I need my slope. Well, did I know the slope of the tangent line? Yeah, that's example 3. That slope was equal to 3. So what I need to do is just plug things in here into this formula. So it's y minus y1. Well, what was the y value? What was f of 1 equal to? Well, recall, this is my y1, which is f of 1, and f of 1 was 2. So y minus 2 is equal to m, again, my m is 3, times x minus x1. Well, x1 was my x value, and in this case, my x value is equal to 1. And then I'm just going to solve for y. So when you're asked to find the equation of the tangent line, you first find the slope, and then you plug it into point slope form and solve for y. So if I distribute my 3 here, I end up with y minus 2 is equal to 3x minus 3. Add 2 to both sides, and y is equal to 3x minus 1. So the slope of the tangent line was 3. But the equation of the tangent line for f of x equals x squared plus x at the point 1 comma f of 1 is this y equals 3x minus 1. Now, if we were to look at this on a graph real quick, because I want to show you kind of what we're doing before we keep going on. So one of the things that happened in calculus is that they wanted to know, okay, well, how do I find the instantaneous rate of change? How do I find exactly how something changes? So remember, our first equation that we had was this x squared plus x. And then the second one, the equation of the tangent line, was 3x minus 1. What happens is, we wanted to say, okay, at the point 1 comma 2, if I want to find the equation of the line that's tangent to that point, how do I do that? Well, that's the instantaneous rate of change, and we needed the slope of the tangent line at 1 comma f of 1, or where the movement away from 1 was equal to 0. And then if we use just the point slope form, we can build the line that is tangent at that point. And so that what we've done is we've figured out, okay, what's the equation of the line that is going to be tangent at the point 1 comma f of 1.